Good morning. So today we are going to cover enterprise risk management, and within this lecture, we should be able to explain the meaning of financial risk management and enterprise risk management, as well as explain the methods that a risk manager can employ in forecasting the losses and the tools that may assist the managers. So allow me to read this case application as it is so that we now see the scope of how the enterprise risk management, what is commonly referred to as ERM, it can be applied in a day-to-day scenario. So an emergency meeting of ABC Furniture Store leadership team started at 8 a.m. on Monday morning. What the heck happened? The company president asked his executive officers. Simply put, we got hacked, replied the CTO. How bad is it and how did it happen? Asked the president. So the CTO replied, Friday night around 7 p.m. The firewall protecting online customer data was somehow disabled. So that data for all credit card orders over the weekend, a total of 415 orders, were compromised. So that customers' data from orders before Friday night were safe. What's our best course of action? The president asked. Let me answer that, said the CRO, who is a chief risk officer and who is now our interest because this can be you years to come. So we shut down the sales website immediately. We've already emailed all our affected customers. We are also calling each customer at 11 a.m. We have a press conference scheduled. You'll state the facts, apologize to the affected parties, and assure our old customers and suppliers that the information is safe, and assure those impacted that we are going to make it right for them. We'll assist them the best way we can, and we'll have identity theft experts available to help them. Sounds like a great plan, said the CTO. How did you come up with the plan so quickly? So remember, this happened on Friday. Now it's Monday, but they already have a laid out strategy. So the CRO replies, we didn't. When we implemented the enterprise risk management program 3 years ago, hacking and reputation risk were two of the important risks that we considered. So we were prepared for what just happened. We want to maximize the harm to our customers and stakeholders and maintain good relations with our suppliers. An enterprise risk management program allows us to do just that. So that is ERM. When we speak of ERM, we've already looked at risks stemming from personal to commercial. And now when we speak of now enterprise risk management, we now want to look at a situation where a company examines all its risk exposures so that they develop a plan on how to mitigate or manage these particular risks. So that is simply the overview. Enterprise now looks at the broadness of risk exposures that an individual or an entity or a company or an organization is actually exposed to. So that an ERM is a comprehensive risk management program that addresses all risks faced by the organization. So this can be pure risks, they can be speculative risks, they can be financial risks, strategic risks, operational, and any type of risks. So this was a case of cybersecurity risk. So it can constitute part of a company's ERM as long as they are exposed to the risk. So that we no longer, ERM does no longer look at one type of risk. It does not look at, let's say, the company being exposed to fire in their offices only, but rather looks at the exposure to fire, the exposure to, let's say, the cybersecurity, the exposure to terrorism, the exposure to financial risks, to operational risks, to strategic risks. All this now forms the ERM program. So we look at how this is done. So you can read all these details, and so you can now look at how do they do this. So we have the ERM process, or the enterprise risk management process, which is similar to any kind of risk management process, which involves risk identification, risk analysis, selection and implementation of the risk treatment measures, and now monitoring of the ERM program and taking any corrective measures or actions. So the only difference we are now saying is that we do not look at one particular risk, but we look at a consortium of risks that the company or organization is exposed to. So the first step in this management of this ERM risk or any other type of risk is what we deem as the risk identification. So you cannot manage what you do not know you are exposed to, and therefore the first step is actually to identify what are the risks that a company or that you as an individual is actually exposed to. So it can fall under any category of or any type of risk, and ideally is just to identify the risk exposure or the risk exposure you are exposed to. So it can be a situation where you are exposed to operational risk, to pure risk, to liability risk, all this. So there are a number of methods that can be employed to identify this risk or loss exposures, and this can take the form of doing a checklist. So a checklist can constitute of the risks, and then someone can go ticking or marking which risks the company is exposed to. It can also you can also identify risk through questionnaires, so that you question your employees or again your customers to be able to identify which risks the company is exposed to. Or you can also use physical inspection. Yeah, physical inspection means you monitoring around the organization and identifying, for instance, probably the staircases leading to your offices are too slippery, and occasionally you've had staff or customers slip and fall. So by you examining that physical aspect, you're able to identify that as a risk or loss exposure. So you can also use financial statements or also the prior history or experience that has been there to now say, for instance, in the last week when the floors were being cleaned, we had a customer fall on the in one of the offices. So that experience can now inform or make you identify that as a new risk exposure. So once you're able to identify, then you can go ahead and now carry out the risk analysis. And the risk analysis seeks to determine how frequent is the risk likely to occur, and how severe or what is the extent of the loss likely to occur. So you are guided by what we call a risk matrix, charting the frequency and the severity. So you'll have your risk there. For instance, let's look at this one, which is field. So let's assume this company is exposed to product liability, competition, reputation risks, cyber attack, fire, and so on. So once they have identified the risks, then they can go ahead and carry out the risk analysis by determining the extent of the loss frequency or the loss severity simply by measuring the levels of impact. So you identify, for instance, a cyber attack is one of our risks. How likely is it to occur? Is it almost nil? Is it slight? Is it moderate? Is it definite? So that in that case you mark it. So assuming it is moderate, Again, so you have identified that cyber security or cyber attacks can moderately occur, and what will be the impact of that occurrence? Will it be severe, significant, or slight? So of course, severe means it will cost the company quite a huge amount. This will be less than severe, but this will be more than slight. So if you identify that it will be severe, then you can now classify it as a severe and moderate case. So the risk analysis helps you, once you're able to assess the loss frequency and the loss severity, you're ideally trying to quantify how much loss are you likely to incur if the risk actually occurs. Because by you measuring how frequent and how severe it is, then you're able to flag the corresponding categories. And these categories are usually such that if you have a risk which is almost nil to occur, but the extent of loss is severe, then you can transfer. If again it is almost nil, but the loss associated is significant or slight, then you can choose to retain the risk. And the extremes, we have them as well. So if you have a case where the occurrence of this loss is almost definite, it is almost sure, and also the severity is very severe, then in that case it is better for you to actually avoid the loss. So to be able to identify these scenarios, it means you have already tried to quantify how much do you stand to lose in terms of the loss severity, in terms of the loss severity, how much do you stand to actually lose in the occurrence of that risk. So risk analysis looks at that quantification so that you're able to assess the loss severity as well as the loss frequency, and then you can be able to categorize into this risk matrix so that you determine whether do you transfer to an insurance company, do you retain it with yourself, or do you reduce or prevent, or do you avoid that risk entirely. So you can look at those examples. So once you have done the risk analysis and developed your risk matrix, then you can now go ahead and select the risk treatment measures that you want to employ. So the risk measures that you want to employ, it can be an issue of what you have identified here. It can be an issue of where you transfer to the insurance company, where you retain and probably create a provision or money set aside to cover for any of that eventuality, or you can choose to prevent. This is where you actually install, let's say, fire sprinklers and so on. So this in this category, we are now looking at the loss control measures that we previously discussed in the previous lecture. So it can be an issue of insurance measures or non-insurance measures. And once you have undertaken the respective measures, then you need to implement those measures and monitor whether those measures are actually working for you or not. So those are the steps: analyze, identify, analyze, then determine the measures that should be put in place, implement them, and monitor their progress. So we have the ERM. We have now emerging risks. So we looked at the various types of risks, and we want to make 3 additional types of risks, what we are calling emerging risks. And the categories can be broadly classified into 3: terrorism related losses, and then losses attributed to climate change, and then cyber liability exposure. So we'll find that traditionally these were risks which were not actually spoken of. They have now come up with time, or they have evolved with time, and they really hurt the cash flow or the financial status of a company if they were to occur. So when we speak of terrorism risk, this is a situation where we have foreign and or domestic terrorists attacking a property directly. It can be through bombs or other types of explosives. And it is it is not new. We as a country have experienced this in several instances. And the risk of terrorism can be addressed through risk control and in some cases insurance. So you'll find that some companies, because of the extent of loss associated with this type of risk, some companies will actually be avoid or actually exclude covering of this type of risks. However, we have situations where solid companies can actually take up this particular type of risk because you appreciate that the frequency is actually rare, but in the event that it does occur, then the loss severity is actually high. So numerous risk controls can be employed so that you'll find that nowadays the aspect of security as you're entering into any building, be it an institution such as a university or a government office or a normal office, you always have a guard, a security guard on board. So that is now a control measure. Yeah. So, for example, physical barriers may be erected to prevent suicide bombers from using a vehicle to reach a building. You may also have screening devices that can check up for metals, metal weapons, and also test air samples to see if explosives are present. So you also have computer networks that can be protected from impenetrable firewalls to prevent cyber attacks. So we shall see that again in cybersecurity. Again, we have situations where key company personnel are instructed on how to reduce the risk of being kidnapped by terrorists. So we have all that. So we can also speak of climate risk. And now these are losses attributable to natural catastrophes, which again, due to global warming, has really increased over the years. So it can be an issue of losses from earthquake, hurricanes, tsunamis, typhoons, droughts, floods, tornadoes, and so on. So we found we covered the fundamental risks in a previous lecture, and we see that ideally most of those risks are actually generally uninsurable. However, because of this climatic change aspect, you find that the aspect of drought has led to food insecurity over the years, or the aspect of floods again can cause a farmer to lose their entire crop. So that companies are now coming ahead and now saying we can actually be able to cover for climate change for a certain group of people. Let's say for crop insurers or for farmers who are actually planting maize, for instance, so that in the event of this adverse climatic change effects that impact their farms or their produce, then the insurance company can actually respond by compensating them for the expected harvest. So we're saying that in this case, government, remember we have said that these are emerging risks. So traditionally, they may not be offered under standard types of insurance contracts, but we now have companies coming into that space. So government insurers, businesses have responded to these increased risks. And we have governments which are now seeking to reduce the carbon emission by restricting the amount of carbon dioxide released by businesses. And again, businesses must also be careful where they locate their structures, what risk controls measures they employed, and the procuring of the appropriate insurance coverage. So we are saying that insurers also can respond to this by providing index-based insurance contracts such as crop insurers to cover for this risk. So a third emerging risk is what we call cyber liability. And this is an organization's data is one of the most valuable assets, which is stored electronically. And therefore, if unauthorized parties who are hackers attempt to access the data for a variety of reasons, then they may be able to learn trade secrets, which they can exploit or sell to other people. And these hackers, when they in this, when once they have possession of this information, they can actually make unauthorized credit purchases using that particular information. So you can see it is quite a risk. And nowadays we have every company collecting data on their customers, so that if you found your information regarding your bank account in terms of PIN, in terms of the amount of balance in your accounts, if you found that information circulating on Facebook, I'm sure you'd not really be very happy. Yeah. And that if that information was again used against you to probably secure loans on Tala and so on, then again you'd not be really amused at it. So to address this risk, organizations with cyber exposures have been hardening their computer hardware through greater restriction, so that you'll find situations where you are always asked to provide a password for each of the transactions you undertake. And then again, they also need to confirm. They also have installed firewalls and automatic reporting of unauthorized access and so on. So you can now look at loss forecasting. So those are the three emerging risks. We can now speak of how our loss is forecasted. And there are mainly three methods: the use of probability analysis, the use of regression analysis, and the use of forecasting based on loss distributions. So we look at the first one, and you can see that's why I said from the very onset that each unit is actually important. You can see here we're speaking of risk, but we're introducing an aspect of probability, which is what you are learning in STAR 111. So it is very vital for you to appreciate each of the units. So if we begin with the first one, so probability analysis looks at the chance of loss as a possibility that adverse event will actually occur. So the probability P of such an event is equal to the number of events likely to occur, denoted by X, divided by the number of exposure units. So that, for example, if you're asked to calculate, if you're given that a vehicle fleet has 500 vehicles, and on average 100 vehicles suffer physical damage each year, then the probability that a fleet of vehicles will be damaged in a given year will simply be equivalent to the 100 that suffer to the number that constitutes the entire fleet. So that will be 20%. So over the years, this can be monitored to determine, is it really increasing? Is it really reducing? So the risk manager should be concerned with the characteristic of events being analyzed, so that they determine what has been the experience over the years. Is it changing or is it improving? Is it getting worse? And these experiences, are some of these events actually independent, meaning that the occurrence does not affect the occurrence of one event does not affect the other. So that, for instance, if you assume our ABC furniture store example, or our case application earlier, has warehouses in Nairobi and Karatina, and that the probability of fire in a Nairobi plant is 5%, and that of Karatina is 4%, then it is obvious that the occurrence of one of these events does not actually influence the occurrence of the other event. So in this case, if the events are independent, then the probability that they will occur together is simply a product of the individual probability. So that in this case, we wanted to evaluate what's the probability that fire occur in both plants, then it will be the product of the probability of fire occurring in Nairobi times the probability of the fire occurring in the Karatina plant, which comes to 0.2% for this case. So other events can actually be classified as dependent. So that in this case, when you speak of dependent events, the occurrence of one event affects the occurrence of the other. So that if you have two buildings which are located close together and one building caught fire, then the probability of the other building catching fire will be increased. So that, for example, suppose the individual probability of a fire loss at each of the building is 3%, then the probability of the second building catching fire, given that the first building has fire, will be actually maybe 4%. So what is the probability of the two fires? This probability is now a conditional probability, which is simply equal to the probability of the first event multiplied by the probability of the second event, given that the first has already occurred. So that the probability of both buildings catching fire will be the probability that the fire occurred in the first building times the probability that the fire is in the second building, given that it has already caught fire. The first building has already caught fire, which you can see is now increased. So that is how we carry out those probability analysis, both for dependent and independent events, and you can see how they arise. So we can also speak of regression analysis as a method of now forecasting. So regression analysis, when you speak of this, I want you to remember your equation y is equals to mx plus c. So regression analysis is another method for forecasting losses, and regression analysis characterizes the relationship between two or more variables and then uses this characterization to be able to predict the values of a variable. So one of the variables, that is the dependent variable, is hypothesized to be a function of one or more independent variables. So in our equation of y is equals to mx plus c, in that case, what we are usually trying to actually model is the relationship between x and y, and our y becomes the dependent variable which depends on x, and our x is actually independent variable. So we can look at an example. So for example, consider workers' compensation claims. So it is logical to hypothesize that the number of workers' claims should be positively related to some variable representing employment, such as the number of employees, the payroll, or the hours the employee has actually worked. So likewise, we would expect that the number of physical damage claims for a fleet of vehicles will increase as size of the fleet actually also increases, or as the number of miles driven each year by the fleet of vehicle increases. So in such a case, we are saying for the workers' compensation claims, we can actually model it to be the number of workers' compensation claims to be equals to a constant plus a constant times the amount of the payroll in the payroll of the amount they actually earn. So this number of workers' compensation claims denote my y, which is the dependent variable. And we're saying that this dependent variable is expressed, or actually it depends on the payroll amount that this worker earns. So my payroll here denotes the independent variable. So this is my y, this is my x, and this is my, so we usually have it as y equals to mx. So this is my m here multiplied by the x, and this is the constant C. So to be able to estimate my beta naught, which corresponds to the constant C, we usually take it to be the average of Y, which in my Y in this case is the number of workers' compensation claims, minus B1, where my B1 corresponds to this M, times X bar, where my X bar here denotes the average amount of the payroll, or the average amount of the independent variable. And then for my B1, so this is my B1, which is my M here, we usually take it to be the ratio of these two. I'm sure you have already seen similar equations, or you have seen this symbol once when you are computing, let's say, the mean or the variance from your statistics class. And what we mean in this case, this symbol simply means you're going to be summing whatever quantities inside here, whatever quantities inside these brackets from I equals to 1 to n. And as we have it here, it means that my first bracket xi minus x bar will be taking the payroll amount for the individual and subtracting it from it the mean. So once you have that number, you'll multiply it with the difference again of the number of workers claimed. So this is my y. So my yi for the the individual, you subtract from it the mean, and that difference you multiply it with the earlier difference, and then you repeat this from the first individual, from the first worker to the nth worker. For our denominator, it means you're looking at the individual claim, that is your the individual payroll amount for the the individual, again subtracting the mean from it and squaring that difference. And once you do that for the first policy, for the first worker, you continue on up to the last worker. So you can see how this is solved in a table. So this is the table that is provided for. So we have the corresponding payroll amounts in thousands. So these are our X's, and the workers' compensation claims, these are our Y's. So I want you to go and apply the two formulas so that you can give me or confirm that the resultant regression line is actually equivalent to y equals to negative 6.1413 plus 0.1074 times x. So forget about the r squared for this particular unit. Just reach this point where you have the regression line, and you're fitting it based on this formula. So this is my regression line here. This is my y, this is my x, and the data is provided for. We are estimating our constants beta naught, b naught, and b1 using these two equations. So that, for instance, my y bar here, to obtain my y bar, I will simply take it to be the summation of all these compensation claims and then divide by their number. And then again for x bar, remember my x is the payroll amount in thousands. I will simply take it to be the sum of all these quantities and then divide by their number. So once you have that, then you can go ahead and determine the second part. So for instance, my x1 corresponds to 400. This is my x1, this is my x2, x3, 4, and so on. This is my y1, y2, y3, y4, and so on. So to determine my first value, xi minus x bar, I will simply take it to be 400 minus the mean I will have obtained for this particular column. To obtain my yi minus yy bar, I will simply take it to be the difference between 18 minus the mean I will have obtained for this particular column. So you do the same for all, and then so once you determine 400 minus x bar and 18 minus y bar, you multiply the difference to obtain your first entry for the numerator of B1. So you do the same for the entire data set. So for the denominator, you're now focusing on the x. So you'll be taking 400 minus x bar. You take that difference and square the difference. And you do the same for all the values within that column. So ensure that you confirm that the entry, this is now your B0 or your B0, and this is your B1. And then you can now predict the number of claims for the next year. So if you're given that the payroll is actually 4.8 million, then if you fit it in your equation, then you find your correspective estimate. So once you have, remember this is the independent. So once you're given any independent value, then you should be able to estimate the dependent variable. So in this case, we're given 4.8 million as our independent variable. And since our amount here were in thousands, we can write this 4.8 million in terms of thousands, which becomes 4,800, so that we can convert or simply replace that where we have the x, and we obtain this as our predicted number of claims next year. So you can also do forecasting based on loss distributions. So in this case, we shall simply look at them theoretically. I'm sure you may cover some of these distributions now or later on in your statistics. And one of the most common distribution, which you know, is probably a normal distribution. And a distribution will help us model how the structure of claim amounts or the claim severity actually follow. So this is a useful tool for a risk manager who is looking into forecasting based on loss distribution, as the loss distribution is actually a probability distribution of losses that actually occur. So forecasting by use of loss distribution works well if losses tend to follow a specific distribution for a large sample size. So that in this case, once you determine that your claim severity follows, let's say, a normal distribution, then what you need to do for you to forecast is actually estimate what are the parameters of the normal distribution inherent with your data. So those are the three methods: probability analysis, regression analysis, and forecasting based on distributions. So I will allow you to go and read on the risk management tools. So Cat 1 shall cover up to the aspect of forecasting. So the rest is simply theoretical. Let me allow you to go and read, and then you can ask me questions in our next class. So ensure that even as you progress on these management strategies or the management tools, right now they are covered theoretically. However, you will encounter them mathematically as you progress, and it is important for you to link them to their use as risk management tools, because then you may cover, for instance, the value at risk as value at risk, but not necessarily tying it to the aspect of risk management. So this theory should serve as a good basis for you to appreciate those tools as risk management tools. So again, our scope of the CAT shall be up to the forecasting, But that does not mean that I will revisit the risk management tools. I will only ask questions. I will only answer questions tied to the risk management tools. So ensure that you read this on your own.